Good morning, all the students. How are you? I hope you all are fine. And welcome to our live sessions, physical science class. Yes, after last 3 days, already we are discussed in our last classes about the laws of motion. Now we are going to discuss about this laws of motion's conclusion. In that one, there is we already completed application concepts. I hope you all are right. It is in your homework notes. Now we are going to discuss about our next concept in our laws of motion. Yeah, somewhat hierarchical questions are there here. Once we go with the first question, yes, in that one hierarchical thinking question. Yeah. Now, a vehicle has mass. Here there is what is the first question? First question is it is a vehicle has a mass of 1500 kgs. What must be force between the vehicle and a road? If the vehicle is to be stopped with a negative acceleration 1.7 meter per second square. Once again I repeat it here. There is a what will be taken here. There is a what 1500 kgs. 1500 kgs. Yes, and what must be force between the vehicle and the road of the vehicle is to be stopped with the negative acceleration of 1.7 meter per second square. There is at that time actually what is the force is there. Okay, clear that all of you that what the force is there for our vehicle. When it is stopped, when we brake it, at that time it is stopped. Braking means already you know very well. In our last lesson we have discussed about this type of problems. But we are not taken at that time force. Here directly you taken force here. The F is equal to MA formula you have to apply here. You have to go to apply F is equal to MA formula. Here M is a given how much? M is equal to given as 1500. Okay, you know very well. What is the M here? 1500 is a given for us. Okay, now, yes, there is a variable. Uh, Simply you take here, this is the mass and there is acceleration you have to take here as what? Yes, 1.7 meter per second square it is acceleration. Yes, and here at that time whatever the force it will be contained, the same force is only become the what? Our opposing force. I hope you understand the students. Okay, now here we take a what? F is equal to MA formula you have to apply here. The vehicle mass is already 1500 kgs are there. Okay, that 1500 kgs are there, and as well as what must be the force between the vehicle and the road of the vehicle is stopped with the negative acceleration of 1.7 meter per second square. Simply there is you multiplied that whatever our mass is given and as well as there is our acceleration is given here. Understood all the students? And that is only will be get for us. May the answer is given wrong in our textbook. Once check it here. Okay, clear or not all the students? This is the first question. Yes, and next come to here our second higher order thinking question. Yes, what is that? Two ice skaters initially at rest push each other. Yes, if one staker whose mass is 60 kgs has a velocity of 2 meters per second, what is the velocity of other staker whose mass is 40 kgs? Already we have discussed about like these problems. Okay, now yes, there is a what? Initially at a rest here. Both are at initially at rest, means what? U1 is equal to 0 and as well as V1 is equal to also 0 only. Here the both are taken as U1 is equal to 0 and U2 is equal to 0 and M1 is equal to taken as somewhat here 60 kgs, and this 60 kgs body contain what velocity? It's a contain 2 meters per second velocity. Yes, one is scatter whose 60 kgs are there, velocity is 2 meters per second. Okay, got it or not all the students? And as well as when you take here it is our skater mass is another mass, M2 is equal to taken as 40 kgs, and what we require? V2 is the required for us. Clear or not all the students? What we require? V2 is the required for us here. Okay, for this purpose, as our whatever the formula is there for our whatever the formula is there for our, for example number 4, the same formula also you have to use here. Okay, now how we take here? There is a M1 V1 plus M2 V2 is equal to 0. Okay, now this formula only you have to consider here. And now automatically what it will become? Yes, here M1 V1 you know very well, M2 we know very well, you don't know about V2. Why? Because we have taken 0 here. Actually, what is the formula? M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. From this one, you when you substitute U1 and U2 is equal to 0, you get this formula. Okay, you have to substitute M1 and as well as the M2 and as well as the V1. Okay, now what is that M1? M1 is 60 kgs. M2 V1 is about 2 here. Okay, now yes, and M2 you know very well, that is about plus 40. Yes, what we required, V2 is the required. Now that is a 40 into V2 is equal to, yes, minus 120. We written as minus 120. Here automatically the V2 is equal to taken as minus 120 minus 120 by 40. Okay, V2 is equal to minus 3 meter per second. The minus is indicate opposite to the direction. Opposite to the direction. Okay, got it? In this way we have to go with our answer. The next come to here. Very important question. This question is very important. That is only the question number 3. Question number 3 here. Okay, what they are taken? 3 identical blocks of each are 10 kgs. Each are 10 kgs. It is a 10 kg and it is also 10 kg. And then after it is one more thing we are considered. It is also 10 kg. Here when we take it like this and here there is a what? The tension here T1 and the tension here we take as a T2. Okay, now when we are applied force on here, got it or not? Yes, what they are asking actually. 3 identical blocks, each mass if it is not there, you write it. Now I will give that question, you write it here. Once again I am given that question to you. You write this all the question. Yeah. 3 identical blocks. Diagram is this one. Write the question. 3 identical blocks, each of mass 10 kg, are pulled as shown on horizontal frictionless surface. If the tension F in the rope is 30 newtons, what is the acceleration of each block? What is the acceleration of each block? And what are the tensions? In the other ropes. Here we are neglecting the mass of the ropes. Got it all the not students? There is a simple thing only it is. Don't confuse about this. Here there is a what is the force is applied here. There is a tension force only. It is a force. 30 newtons force is applied here. And here because of there is a 30 newtons force are applied. And what is the total mass at this particular thing? What is the total mass? Here 10 plus 10 plus 10. Mass is the 10 plus 10 plus 10. What is the total mass? M is equal to here M1 plus M2 plus M3. Okay, now automatically the total mass is the 30 kgs here. Total mass is the what? 30 kgs. It is not a like Atwood machine question. Atwood machine is nothing but should be in hand on the pulley. Here it is not like that question, a general question only. Okay, now based on F Newton's second law. Yes, here simply what the forces are there? 30 newtons. F is equal to 30 newtons and M is equal to how much? M is equal to how much? Here M is equal to taken as 30 kgs and F is equal to what? MA. Here A is equal to F by M. Okay, clear or not all of you students? Then simply A is equal to become what now? A is equal to F by M. Here F is equal to 30 and as well as M is equal to also 30. That's why it is 1 meter per second square. Got it or not all the students? F is equal to, yes, A is equal to 1 meter per second square. Then come to the tensions. At this particular, there is very well about the tension on this last one. Okay, now, but we don't know what is the individual tensions here. When you take here only the first one up to here T1, up to here there is only we are taken. Yes, now the tension is also written in the terms of force also. That's why it is taken as MA. Okay, now MA here you take it is the M1 into A. The acceleration is the same in every way. Okay, clear or not all the students? Yes, and there is due to this mass change, there is what is the change is occur for us? The tension also the change is getting for us. That's why T1 is equal to F1 you take here, that is taken as M1A, and T2 is equal to taken as F2 here, that is taken as M2A. Got it or not all? In this way only we have to conclude about our concept of our tensions. Okay, once you check it out here, there is a whatever this force is taken as here, the force is taken as M1. Got it or not all the students? This force is you take it is a M2, this force is taken as it is M3. Okay, now when we are taken a single one here like this 10 kgs of mass and as well as we are giving force here F1 and acceleration for this one already we are finding. What is that acceleration? A is equal to taken as 1 meter per second square. Yes, acceleration is this, mass is this one. Automatically you know get the what is the force, that is only T1. Okay, the T1 is equal to written as when it is a horizontally. Yes, when it is a vertical, like that only you are taken as a vertical here in this manner. Okay, clear not all of the students? There is in this manner you take here, there is answers are made changes here. Clear not all the students? The vertical manner, there is a horizontal manner, that's why there is no acceleration due to gravity. When you take the same thing in a horizontal manner, when we hang it is like this. Okay, clear or not all the students? It is both are under the acceleration due to gravity. The working loads are under the acceleration due to gravity. There is a not working like the things here. Okay, now there is horizontal, that's why horizontally tension is taken as MA. Now automatically it is become 10 into 1. Then come to T2. Then come to T2 here. When you take here T2, at that time there is you take a part of. Okay, now like this you have to take here. Both the things you have to take here. There is a T1 and as well as it is a T2. Here 10 kgs and 10 kgs. And there is also acceleration is how much? 1 meter per second square only. Okay, that's why the t2 is equal to taken as 10 plus 10. That is, it is become 20. 20 into 1. That's why it is a 20 meter per, sorry, 20 newtons we are taking. 20 newtons. In this way only you have to calculate our force. Okay, now when it is a given horizontal. When it is a given vertical, you should compulsory take the what? Yes, our Atwood machine applications. Atwood machine applications you have to take. Okay, now this one more thing. Here all the things are identical masses only. In case it is not identical, when you are taken a vertical, different tensions may get for us. Clear or not, all of you? Yes, there is a what? mg. T is equal to taken at that time as a mg. Okay, got it? That is only the about our concept we have taken for our higher order thinking question. In the next, further we come to here one more higher order thinking question. Yes. Yeah. What is that? Fourth one. What is the fourth one? Once we have to take here. Yes. If a fly collides with windshield of a fast moving bus, yes, is the impact force experienced same for the fly and the bus? Why? Yes, is the same acceleration experienced by the fly and the bus? Why? Okay, clear or not, all of you? Suddenly there is one fly may, yes, fly and it will be collide with the bus. At that time we are going with the discussion of impulse. Yeah, there is a what? Impulse are working. Okay, on the fly. Okay, clear or not, all the students? Yes, why? Because there is a sudden, it is a sudden process, or otherwise it will be take a time. Okay, now, yeah, there is a when you take here is the impact experienced same for the fly and the bus. Okay, clear or not, all the students? Yeah, there is, it is affected, but it may not appear for us. Okay, there is a more mass is there for the bus. That's why it is what actually the momentum that much of not affected the bus, but the momentum of the fly may affected. Where the impulse on our fly it is appear for us. There is a change of momentum is considered in the fly. Okay, clear or not, all of you? Yes, there is it is a contain high velocity bus, and as well as there is it is a contain low velocity, and as well as the less mass it will be there. That's why the momentum change may consider here. Yes, and is the same acceleration experienced by the fly and the bus? Yes, same acceleration is experienced. No, it is. Your bus acceleration is not affected, but our fly acceleration is affected. Okay, clear or not, all the students? Yes, and why? Because it is because of its masses. Because of its masses only. Yes, no other thing is the main role played here. Okay, this is only about our fourth question answer. Okay, come to here our whatever the multiple choice questions are there next year, multiple choice questions. Got it or not? Yeah, there is a multiple choice question. First one. Every student, please, it is not possible to write on the board. Once take it here. First one. The scientist who said that an object in a motion will remain in same motion as long as no external force is applied. Got it or not, all the students? The scientist who said that an object in a motion will remain in the same motion as long as there is no external force is applied. It is the first given by the whom? Galileo. Okay, clear or not, all the students? First given by the whom? Galileo. Once go with the page number, yes, there is a, don't confuse here. The first who is a given it is. Okay, now, yes, Galileo only, go for the page number, yes, 31. Galileo stated that an object in a motion will be remain same motion as long as no external force applied on it. Page number 31, you have that statement. Okay, now, clear or not, all the students? Second one, if net force acting on object is 0, then the body is said to be in the state of equilibrium. You know very well about this one also. Yes, if the net force acting of an object is 0, then the body is said to be, it is in the state of equilibrium. Not is it in motion, not in an inertia motion, or not in a uniform motion. Yes, and the next one is the inertia of a body, it depends on, you know very well. Inertia is totally affected by which one? The inertia affected by the mass. Clear or not, all the students? Inertia affected by the mass only. The next to come to here, yes, fourth one, Newton used the word mass of inertia, mass like motion to represent, mass in a motion represent. It is a linear momentum, it is inertia of motion, it is a velocity, inertia at rest. The mass of motion, mass in motion, to represent it is a what? Yes, inertia of motion. It is a represent inertia of a motion. Okay, clear or not, all the students? This is only about our Newton's word, and as well as there is all the things, and the most 4 questions are only there. One more question is also there. The SI units of momentum is a what? kg meter per second. Kg meter per second. Answer is C. kg meter per second. Why? Because it is the product of velocity and mass of the body. That is only. Next, come to here. From what experiments are there? If possible, you have to do here. Conduct the experiment to prove the Newton's first law of motion and write a report. Okay, the page number is the 48. I am going for it is. Page number is the 48 here. Yes, and conduct the experiment to prove the Newton's first law of motion and write a report. You take here different things are there by the carom. Okay, now or you take coins, okay, now money coins you take here, okay, now yes, and by using it also. Otherwise, you take a glass of water and a thick sheet, and you take a massive coin. Okay, suddenly you take it is okay. Now I will send that all the information by tomorrow into our whatever our recording classes are there. In that one, I will provide all activities also. Why? Because it is not possible to do the activity in our classes. Okay, now everything it is not possible. That's why there is I am given. I want to given in that particular recording classes. Once you check it here. Okay, clear or not, all the students? Whatever the activities are required to do. Okay, throughout our chapter. Okay, once you check it here. And next to come to here, write a report on the action. Write a report on, conduct an experiment to show action and reaction force acting on two different objects. Okay, clear or not, all the students? So many things are possible to here. Yes, already we taken a balloon rocket. Okay, now, and you take here, it is not possible. I hope there is whatever experiment is there in our lesson. What is there? You have to take here test tube, and that one you take a water, and whatever the vapor of the water may, after heating it will be Yes, that our test tube is going far backward, and whatever the carp, rubber carp we are attached to it, it will move forward. In that one only you are take here that our action and reactions, and here you know very well. Yes, when you take a duster, otherwise there is you take what it is, rubber bands. Okay, when you take a rubber bands, it works as a action and reaction purpose also it is used. When you take a rubber band, okay, now that will be when we stretch the rubber band, automatically again comes to its ready to comes to its original position. Every action is a given reaction with the same magnitude but opposite in the direction. Okay, that will be also get for us. Okay, now so many things are there. It is possible to you do it all the things. Okay, when you are pressing our board, we feel the board is also pressing on us. Pressing force is getting on us as an action and reaction mode. Okay, and next to come to here suggest what projects. You have to do these projects compulsory in your homework. Okay, now what that? Observe some daily life examples of Newton's first law of motion and explain the situations. Write a report on your observation. Already we are completed about these things. Correct or not? Already I am given as a homework for you. Yes, you have to complete that all the projects around you. What the Newton's first law of motion? There is so many things are there. Okay, now yes, before that it is in a rest, afterwards maybe applied force on it, it will be coming into the motion. Like the things, so many are there. Okay, now yes, and you have to write all the things. Somewhat are remain as in a rest only because of what we are not applied a force on it. In our home there is all the whatever the TV or fan, they are fixed in their position. Why? Because we are not applied any external force on it. That's why they are not moving from their position. In case you are applied a force on it, there is a what? It is a moving. Like that, you take our daily life situations. Okay, now around you there is about the vehicles also. Okay, now so many vehicles are may not move up to apply the mechanical engine force on it. After applying on it, it automatically changes. Okay, in this way you conclude about our all our concept of our what is that projects. And the second one come to here. Write a report on the action and reaction in the same system that you have observed in your daily life, which are the evidence of Newton's third law of motion. Once again I repeat it. Write a report on the action and reaction in the system that you have observed in your daily life, which are the evidence of Newton's third law of motion. This also already completed. About this one also we already completed. Yes, in our regular homework you have to take it is in again our homework notes in a project manner. Okay, all the students, you have to go it is in a project manner. Yes, in our whatever our lesson is there. Okay, yes, please complete all the students whatever these all the learning objectives are there. Yes, improve your learning concepts are there in your homework compulsory. Complete that all, and as well as you collect more for problems. Okay, now more numerical problems from somewhere, from the net, otherwise somewhere you have to collect it. I am also provide somewhat worksheets for you about for numerical problems and as well as somewhat higher order thinking question purpose. Okay, further. Okay, yes, this is about our laws of motion. I hope you are understood this laws of motion lesson clearly. Yes, there is whatever the Newton is a given, whatever the Galileo is a given, whatever the Aristotle is a given, and as well as what the momentum and what the conservation of momentum, what the impulse. Okay, these are the main components are there in our lesson. Yes, and once go through once again this lesson. Most probably in this weekend we have this examination, yes, of our this one. Yes, this examination we are taken for it. Okay, clear or not all students? This is only about our laws of motion. And then after we have one more important lesson, that is only refraction of light. Refraction of light at a plane surface. Tomorrow onwards we go with our new lesson, that is the refraction of light at a plane surfaces. Okay, now already in a 7th class you discussed somewhat about the reflection of light. Okay, now and first we have to know what is the light, and then after we are enter into our next lesson. Okay, clear or not all the students? Once again I will repeat it here. What is the light? In our 7th class we already discussed it. Okay, now yes, this is the one of the property of light, that is only the refraction of light at a plane surfaces. Okay, clear or not all the students? And here reflection, about the reflection you already studied. Yes, anyone can you give what is the reflection? What is the reflection? What is the reflection? Nobody have idea? How I am observed by you? It is how to possible to see my picture in your mobile. There is an extra to the technical thing. Once you don't take account of our communication system, how it is possible to see my picture on your screen because of reflection of light only. Okay, very good. Bouncing back of light, that is only called reflection. When the light is fall on us and again it is a reflect, again it will be fall on which one obstacle. Yes, again it is returned back into the same path. It is only called what? Reflection. The tube light, whatever the light is produced, it is a fall on me, and afterwards I am the obstacle for the light. That's why it is returned back into the same path or same plane. That is only called the reflection. Okay, clear or not all the students? Once we are, what is the light then? What is the lights? Yes, we concluded after that. Okay, what is the light? Light is energy form. What is the light? Light is energy form which is coming from luminous body, and it is fall on our retina and give the sense of vision for us. Got the students? All the students got it? The definition. Light is energy form which is coming from luminous body, which is coming from luminous body. It is a fall on our retina. It is fall on our retina. It gives the sense of vision for us. It is give the sense of vision for us. That is only called what? That is only called what? Light here. Okay, got it or not all the students? It is only called what? Light. Yes, and here there is a what? It is a light is energy form. Light is energy form. So come from where? Come from luminous bodies only. It is fall on our retina. Then after it will be gives the sense of vision for us. Got it or not all the students? The light is came from where? Compulsory they came from luminous body only. Okay, now luminous body may illuminated the illuminous body. Got it or not all the students? Suppose the sun or otherwise the tube light or candle, these all are what? Luminous bodies. What is the luminous? What is the luminous? Anyone? What is the luminous body? What is the non-luminous body? What is the luminous? Luminous is nothing but which itself it produces the light. That source is called luminous. Itself it produces. Whatever the substance are contained inside it. Okay now? Yes. that is by itself it only. There is not depending on other one. Okay, we are now luminous bodies. No, I am not a luminous body. Okay, now you are also not a luminous body. This board is also not luminous body. Earth is also not luminous body. Moon is also not luminous body. Luminous is nothing but itself it produces the light. It is called luminous. How? There is a like a candle. Itself it is only produces. Whatever the substance contained inside it, it is losses. Moon is not a luminous body. Don't write the moon is a luminous. Moon is not a luminous sun. Bulb is a luminous. Okay? Clear or not all the students? And suppose you take a candle, and the candle, whatever the wax is there, that is only produces the light. Moon is not like that. Suppose you take a sun, on the sun helium gas is there. Okay now? Yes, the fusion of one particle with another particle. On the sun there is a what? Yes, hydrogen gas is there. That hydrogen gas components are, one is a combined with another one. There is a helium gas that produces for us. That is only produces the light in the process of nuclear fusion. Okay, suppose you take our tube light. In that one there is a inert gases are there. That inert gas are what undergoes the reaction due to the current, and that is produces the what actually light for us. How the non-luminous? The non-luminous bodies are illuminated by the luminous body. Okay, Earth, it is why? Because at somewhat time it is dark. You know very well. It is called night. Why it is called night? Why? Because Earth is not the power portion of Earth is not in front of the sun. Because of that, it is not brighted. It is not become illuminated. Okay, clear or not all of you? Yes. And moon is also like that only. Somewhat days are not moon days. Somewhat days are full moon days. Why? Because it is called not moon day. Why? Because it is called full moon day. If it is a luminous body, not like that it is possible. Got it or not understand? That whatever the light is fall on our earth, it is reflected and it is fall on the moon. That portion may illuminate it. Okay? Because of that is called non-luminous body only. Okay? Yes? Moon is not a luminous body. Once again I repeat it. Yes? About that thing, tomorrow we have to go to discuss. It's a interesting concept and as well as the important concept for your 10th class also. Okay now. Thank you students. Bye. Take care. Complete our third lesson. All the homeworks and the question answers. Bye. Take care.